Welcome back! In the last lecture, we took a look at Bettercap, one of the most complete and advanced man-in-the-middle attack framework. Bettercap brings man-in-the-middle attacks to the next level. Let's start a man-in-the-middle attack of type ARP poisoning using Bettercap. We'll intercept all the traffic between Windows, the recording machine, it will be the victim, and the default gateway. We'll see all internet data sent and received by the victim. The attacker who runs Kali is connected to the same Wi-Fi network as the victim and the default gateway. Kali runs in a VM and the network is set to bridged mode. Let's start Bettercap. Bettercap -iface and the name of the interface, ETH0. To insert in the middle of the connection, we'll use a module called ARP.spoof. Let's see the help of the module and what are the available options. Help, ARP.spoof. We see that the module is not running. We start it by executing ARP.spoof on and we stop it by executing ARP.spoof off. There is also the possibility to launch a denial of service attack, not a man-in-the-middle, using ARP.ban on. In this case, Bettercap will intercept the traffic and then drop it. We'll see shortly how to do that. We also see the available parameters of the module, a short description of each parameter, and its default value. There are two parameters or options that are of interest to us at this moment, arp.spoof.fullduplex and arp.spoof.targets. Let's take them one by one. arp.spoof.fullduplex will make Bettercap to spoof both the victim and the default gateway if it's set to true. If it's set to false, which is the default value, it will spoof only the victim, not the default gateway as well. In this case, we cannot inject packets and data in the connection between the victim and default gateway. We'll talk more about injection in the next lectures. Note that the default gateway could have some anti-spoofing features like dynamic ARP inspection activated. If it's the case, we cannot spoof the router and we have to set this option to false. To change the value of an option, any option of any module, we execute set, the name of the option and the value. For example, set the option and the value, true. When you change an option, you can use tab to autocomplete that option. It's the Linux style of running commands. For example, AR and I'm hitting tab. And it has auto-completed the option. F, U and tab. Okay, you've got it. And I want to start also the net.probe module for it to be able to discover the targets. So net.probe. On. The second important option of ARP.spoof module is ARP.spoof.targets. It's used to specify the host targets as a list of comma-separated values of IP or MAC addresses. Let's set the target as being the Windows machine. Let's see what is its address, IP config. And this is its address, 192.168.0.113. So set arp.spoof.target and the IP address of Windows. Now that we've set all the required options, we can start the module arp.spoof on. ARP spoofer started, and there is one target. There is no error, and I'll check that the module is running by executing help. And we notice that besides the modules that were running, arp.spoof is also running. Take notice that net.probe and net.recon must be running as well. Let's check that the attack has been executed successfully. Let's see the MAC address of the attacker. In another terminal, I'm executing ifconfig. And this is the MAC address of the attacker. It ends in 76. And on the victim machine, let's display its ARP table. ARP-A. And we notice that both the default gateway and the attacker have the same MAC address in ARP table. Now, when it wants to send a packet to the default gateway or to another address on the internet, it will search for the MAC address of the default gateway in the ARP table and use that address. This is the default gateway, and this is the entry for the attacker. The attack is running. The information like emails, credentials like usernames and passwords or other sensitive data will be intercepted by the hacker who is in the middle of the connection between the victim and the default gateway, which is also the access point of this network. To save and see the captured packets, we should use a program like Wireshark, or we can start a Bettercap module that does the job. And the Bettercap module that sniffs and then displays sensitive data is net.sniff, and we must start it as well. Net.sniff on. Okay, let's test the attack. From the victim's machine, I'm gonna visit a website and then log in. And the site is demo.testfire.net. I'm clicking on online banking login, username Andrei, and the password test1234, and login. The authentication was not successful, but that's not important. Back to the attacker's machine, we notice in Bettercap window the communication between the victim and that website. This is the communication. The website I have visited, and here we notice the credentials, the username and the password. Of course, that connection was not encrypted. It used HTTP instead of HTTPS. We'll see in the next lectures what are the possibilities a hacker has to bypass the encryption and sniff encrypted traffic. If we want to be more verbose, so to display all the information that was captured, we set an option to net.sniff. Net.sniff.verbose true. And we see each packet. At the end of this lecture, I want to tell you a troubleshooting tip. If you don't see the credentials, the username and the password in Bettercap window, it doesn't mean that it didn't capture them. Bettercap does not display all captured data, but only a part of it. Normally, net.sniff module should capture and then display the credentials for well-known protocols like HTTP, but from my experience I can tell you that's not always the case. First, I'll set this option to false. What you can do is to set an option of net.sniff module to save all captured data to a pcap file that can be later opened in Wireshark. Let's see the options of net.sniff module. Help net.sniff. And this is the option. So set net.sniff, output, and a file. For example, /root/win.pcap. Bettercap will save to that file all the captured traffic, and you can later open it using Wireshark and search for traffic of your interest like credentials. And to stop the spoofing attack, arp.spoof off. It's restoring the ARP cache.